All right, guys. So probably a relatively quick video today. We're just looking at kind of a review, a reminder of statistical tables and graphs, what they are, how you put them together, how to read them, that sort of thing. And usually this is one area that most people do pretty good at this point. By the time you hit your senior year, even on the ACT test, this is one of those areas a lot of you perform well at. So hopefully this kind of goes along with what your understanding is already. But the first type of table that is used in statistics is a frequency table. So right here, we've got some information. It says that a teacher makes the following list of the grades that she gave her 25 students on an essay. And then it gives us a list of what those grades were. So A, C, C, B, C, D, C, C, F, D, and all these different grades, right? Now, the problem with listing it out this way is that it's hard to see what that data means. I see a lot of C's up here in the front, but as we get over here, all of a sudden I start seeing A's and B's pop up more, but I'm not sure exactly what is happening in the big picture. So one thing that we create is called a frequency table, and it's just a table with a couple of different columns here. And the first column is our different categories, okay? So what we're measuring are the grades, okay? The grades are what we are measuring, and there's different categories of grades. So this first row is all of the A's, and then all the B's and C's and D's and F's. And the second column is frequency, or in other words, how many are there? All right, how many A's are there? How many B's? So it says there's 4 A's, 7 B's, 9 C's, 3 D's, 2 F's. Looking right here, it's a lot easier to kind of gain an understanding of the big picture, right? A few got A's, a few got F's. The majority are somewhere in the middle, leaning towards that little higher BC range, all right? Some of these tables are going to add a little bit more information. Relative frequency. This is one of those that we have a formula for it, but most of you are going to just do this automatically. Relative frequency is a percent, okay? And what it does is it says, compared to everybody, how many are in that category. So for example, the relative frequency of A's, if I added another column right here, relative frequency, I know that there's 25 total grades. 4 of them are A's. So 4 out of 25 are A's, which means 16% are A's. Okay. B's, there are 7 out of 25 of them that are B's. So that means what? 28% got a B, and 9 out of 25, and so on and so forth. So you just take the frequency that it happens in that category and divide it by the total frequency of all of them put together. And that gives you your relative frequency. That gives you your percent of the total. There's another frequency, and this, we're going to bring it up because I see it being used. But the cumulative frequency is just so relative. What the cumulative frequency is that category plus all of the other categories before it added together. So my first category of A's, there's only 4 of them. Okay. My second category B, there's 7 of them, but I've already got 4 from the A's. So there's actually 11 for my cumulative frequency, meaning I've already counted 11 of the total. When I get to the C to get my cumulative, I just add everything that came before the C's. And here's why this is just, what if you're counting from the bottom? Then up here on the 4, my cumulative frequency would be 25. But if I'm counting from the top, it's 4. And so this number right here, the only time it really helps is if I were saying something like, how many got an A, B, or C? And then rather than having to count the A's plus the B's plus the C's, I could just say, oh, there's 20 of them that are counted up to that point. I still think it's easier to just add the 3 together, but that's what that category means. It's going to come up on the homework. You're just going to have to fill it in. That's how you do it. Example 1 gives you this same table up here, but it wants you to add the relative frequency and the cumulative frequencies, which I already started doing right here for you. So the relative frequency, you just find the percent of the total. So you take how many out of the total amount, and it gives you a percent. If you have a hard time going from decimal to percent, at this point, you need to times it by 100 if you want it to be in percent form. Otherwise, you'll just see the decimal version of it. Okay. All right. Moving on. There's different types of data, and depending on the type of data that we're measuring, we might want to use one type of graph or another. So the 2 main types of data are qualitative and quantitative. And at this point, I think you have all heard those words quite a bit. Quantitative sounds like quantity, which means that you can count it, you can measure it, you can assign a number to it. Okay, you can count it or measure it. That makes it quantitative data. Qualitative data is something that doesn't have a numerical value. So if I was asking what color of hair is most common in the school, you can't use a number to represent a hair color. You can count how many people have a hair color, but the data, the hair color, is not a number. The data itself is a qualitative data. It's a color. All right. So example 2, actually, you know what? Going back up here, I kind of skipped over reading some of this, but I want to, when we were assigning grades, we said A through F. Those are qualitative because they're not represented as a percent of your score. They're represented as A's or B's or C's or D's or E's or F's. If the teacher had given them 95% and 82% and 37%, this would be quantitative data, but because they aren't a numerical value, they're qualitative. Okay. So in these examples, brand names of shoes in a consumer survey, then the brands of shoes is not something that you can count. So that is qualitative with an L. The heights of students, heights is something that you measure. So that would be quantitative, like quantity, because you can measure the height. That's a number. Audience ratings of a film on a scale of 1 to 5, where 5 means excellent. Now, this one we have to be careful because they are assigning a number 1 to 5 based on how an audience rates a film. But how an audience rates a film, they're actually rating it as excellent or poor or some other word. And then the study is assigning a number to it. Even though it has a number assigned to it, you can't measure how much a person liked a film based on the word excellent. You can't say, oh, they liked the film 7. That doesn't make sense. It has to have a number that you are counting or measuring to be quantitative. So this one would be qualitative, not quantity. All right, moving on. Example 3. Just a quick, and I'll show you an example below. We're not going to spend a lot of time, but bend exam scores. All that means is, for example, if I was making a frequency table of these scores the way that they are, I would have so many categories. I would have 94, 93, 92, 91, 90, 89. And a lot of these categories, there's only one 94. I don't even see a 93 or a 92. Oh, there's one 91. So sometimes the way the data is put together, it doesn't make sense to use one number for each group. So what binning means is basically you just group some of these together. So for example, you might say, instead of making categories of every individual score, let's do like 96 through 100 as a category. And that means I would do 91 through 95 as a category. And then 90 down to, oh, see, now I'm going backwards. So this would be 86 to 90 as a category. And then 81 to 85 as a category. So you're just grouping data together within a bin, a group of scores. The few things that are important, these sizes need to be equal. Okay, I can't make one group 96 to 100. I can't say, okay, 96 to 100s are right here, and then let's do 85 to 95. If you're going to bin them, they need to be the same size of bins. So for example, that test that we were just talking about, they grouped them. They didn't go all the way up to 100. They went from 95 to 99, and there was only one person. From 90 to 94, there were two people within those numbers. Notice that they don't overlap at all. 89 doesn't overlap anywhere else. And not only that, but the way this is written, there's scores in between 89 and 90, but apparently those can't show up. What if someone got like an 89.5? They wouldn't be in this category or this category, which means to me that no one can get an 89.5. So you got to make sure that all the data can fit within that bin that you're examining, okay? So in the homework, it's going to give you some tables with some of this information, and then it'll give you a list of numbers, and you might have to fill out the frequency, and you might have to fill out the relative and the cumulative frequency. But you're not going to have to create the entire table from scratch. It'll give you the categories, and a lot of times it'll even give you the frequency, depending on what it is asking you to put together. Okay, bar graphs and pie charts. You guys are very familiar with these. So if you want to pause the video and read through all of this, these are just some of the important labels for a graph. And I can't count how many graphs I see presented, especially on social media, that don't have these labels that are so important. So the first one is a title of some sort explaining what the data is, where it comes from, what it is. You need to have a vertical scale and a title. So not only does this need to say frequency of the grade, there need to be numbers applied to it, okay? You can't just ignore the numbers and only have the pie chart, because that doesn't, who knows what the difference between this spot and this spot is. That could represent 1,000 kids, or it could represent one kid, or it might represent 1 point on a grade. So without those numbers, that scale and the number and the title, you don't really know what it's talking about. You need to have the horizontal scale going across. And usually when we use these bar graphs and when we use pie charts, which we'll get to in just a minute, usually this is not quantitative. This is usually qualitative data. Not always. Sometimes we do this with quantitative, but usually this represents a qualitative set of data, like the A's and B's and C's and D's, okay? It's also important, if you need to have a legend. Sometimes, like on this pie chart, sometimes it doesn't tell you in the pie chart what each of these pieces is. So off to the side, you might need something that says green is A, kids that got an A. Orange are the F's. That represents those that got an F, okay? And the last thing to remind you, well, I guess before we get to the pie chart, this bar graph on the right-hand side has a relative frequency, and on the left-hand side, it has just the frequency. Most graphs don't have both. But if it does, if you're going to put the frequency and the relative frequency, make sure that they match, okay? Make sure that 24% right here represents 6 on the frequency table. I've seen a lot of graphs where this side gives the frequency, but when you look at this side, the numbers, the percentages don't match what they should based on the other side. So be careful of that one. And then on the pie chart, most of you are pretty good at making these pie charts. If you have a hard time creating one, Where most people struggle is, well, how do I figure out what angle this chart is at? And the way that you do that is right here. The wedge angle is what that's called. You take the relative frequency. So like the number of students that got a B was what? It was 7. So you would take the number of students that got a B, and to get the relative frequency, I have to divide that by 25 students, which gave me 28%. And then I take that percent and I times it by 360 degrees, because there's 360 degrees all the way around. So you have to times by the percent of the total to figure out how big is that pie chart going to be right there. Okay, moving on. You've seen enough of those. I'm comfortable with that. Histogram and line charts. If you are using quantitative data, this doesn't mean you can't use a bar graph and you can't use a pie chart. But with quantitative data, we usually don't. We usually use what's called a histogram. And the difference between a histogram and a bar chart, first of all, is that our graph, if you notice that each of these bars that goes up is right next to the next one. That's because our data goes from one chart to the next. There's no gaps in the data unless the frequency is 0. Then there might look like there's a gap there. But those bars connect to each other, and each of the bar represents a category or a bin. Okay. So the 70 to 75, notice this doesn't just represent the 70s, it represents anyone between a 70 and a 75. This bin right here represents anyone from a 75 to an 80. All right. And depending on these labels, again, there's not going to be an overlap. Someone with a 75 isn't going to go into both bins. Usually, the 75 is going to be this starting point. Okay. So when I would read this, I would assume anyone from 70 to 74.9999 is going to be in this bin. But once you hit 75, now they jump into this bin up until they get to 80. Because once they get to 80, they jump to the next one. The line chart uses the same information, but instead of drawing the bars and the histograms, it uses a dot to represent the frequency. So right here, my frequency, just like in the bar graph, I have to have the same labels on my chart. But here, my frequency is 4. And it's the same on the line chart, but instead of a bar right there from 70 to 75, right in the middle of that bin is a dot at 4. So what that means is that's the midpoint from 70 to 75. That's where the frequency lies. And then the next one is going to be between 75 and 80. And depending on what you're trying to show, you might want to use, they tell you the same thing. This one I think is a lot easier if you're really interested in the groups. The line charts, I think, give you a better idea of trends. Like it's really easy to see on this, oh, this is going up and then up again, and then it goes down and flattens out and then down and down and down. Where over here, the width of the graphs gives you a little bit more information about what group is in that one. I don't like looking at line charts and trying to think, okay, this is in between 70 and 75. This tells me that. That's right there in the picture. On this one, I have to kind of figure that out looking down here below. So example 6, it gives you a table right here on the left, and it shows the ages of all the Academy Award winning female actors through 2017. Make a histogram and a line chart. So it tells you that from age 20 to 29, 32 female actresses won an Academy Award. 34 won it when they were between 30 and 39. 14 won it between 40 and 49. So you notice a trend. The younger actors are winning it more often than older actors, which makes sense. They're probably in more movies and more busy and more popular than maybe some of the older ones. I don't know why that might be. I can think of a lot of older actors and actresses that I like way more than the young ones. But that's what the data is telling us. And so when you apply that to here, if you're doing the histogram, your width of your bars are going to be 20 to 29. So I start at 20 and I go up to 30. But I'm going to stop at 29. And so I'm going to have 32 people in that graph. And so over here on the left, my frequency, it should go a little bit higher than 30. Okay. And again, you guys have done this before. All right. You have made these graphs. Just be really careful when you're doing the widths of them as you create them on any of the homework. Okay. All right. I guess that's it. Is there anything that we missed? I think we covered what we wanted to. So homework, now we are doing homework 5C. Hey, if you want to start that at home, you are welcome to. If you want to wait and work on that tomorrow in class, we'll be working on that together, and I'll be answering questions if you get stuck on anything there. Good luck.